Observability is a concept in software engineering that refers to the ability to understand and diagnose a system's behavior and performance through the collection, analysis, and visualization of its internal state and external interactions. In other words, it is the ability to observe what is happening inside a system without having to rely on guesswork or assumptions. Observability is important because it allows software engineers to identify and troubleshoot issues more quickly and effectively, as well as gain insight into how the system is performing and how it can be improved. To achieve observability, a system must generate and expose relevant data in a way that can be easily analyzed and understood by humans or machines. This may involve instrumenting code, logging events, monitoring metrics, tracing requests, or analyzing system performance in real time. So, in simple words, throughout the lifetime of an application, it is vital that you are able to understand what is occurring and what has occurred within the system. That is what observability is all about. Achieving observability in a system typically involves several steps. So, here is a high level overview of the common steps involved in this process. The first is identify. Identify the key components and subsystem of the system that require observability. This may involve determining which part of the system are critical to the overall performance and functionality of the application and which ones are most likely to encounter issues or bugs. Then we define the metrics and logs that need to be collected from the system. This may involve defining what data points are important to monitor, such as request rates, response times, error rates, or other key performance indicators. Once we have identified and defined the metrics, we implement the instrumentation in the system to generate and collect the relevant data. This may involve adding code to the system to log events, collect metrics, or trace requests as they move through the system. Then we aggregate and store the data generated by the system. It's about using the tools like logging frameworks, monitoring platforms, or databases to collect, store, and analyze the data. And then we visualize the data to analyze it further. And it's about gaining the insight into the system's behavior and performance using the dashboard, charts, or other visualization tools to display the collected data in a way that it is easy to understand and interpret. Using the insights gained from the data to identify issues and troubleshoot the problems. It may involve using the collected data to identify the performance bottlenecks, diagnose errors or bugs, or make improvements to the system's architecture or design. And then finally, we must iterate on the process by refining the metrics and logs as needed, improving the instrumentation to capture more data, and using the insights gained to make ongoing improvements to the system. Another popular term which is related to observability is monitoring, and we call it the art of monitoring, a practice of effectively and efficiently monitoring a system or application to gain insight into its behavior and performance. This involves not only the technical aspects of setting up monitoring tools and collecting data, but also the process of using that to inform decisions and make improvements to the system. So, monitoring is a critical component of observability. It allows developers and operators to understand how a system is performing and identify potential issues before they become critical problems. The art of monitoring involves selecting the right metrics and data points to collect, as well as determining the appropriate thresholds and alerting mechanisms to ensure that potential issues are identified and well addressed in a timely manner. So ultimately, we can say that the art of monitoring is an important aspect of observability. It's about using the data to drive improvements in a system, whether that involves identifying and fixing bugs, optimizing performance, or making architectural changes to improve the overall reliability and resilience of the system. And by combining the technical know how with an understanding of the system's goals and objectives, practitioners of the art of monitoring can turn the data into actionable insight that drive real world results.